SwayamPrabha. Digital India. Educated India.
I welcome you all to the session of thermal engineering basic and applied, and today we shall solve two numerical problems from boiler. So, you know that I have written here boiler stroke steam generator because boilers are also known as steam generator, because the essential function of boiler is to produce steam, and that is why it is also known as steam generator. Okay. So, let us look at the problem 1. So, let me read out the problem statement first. For lab scale experimental setup, steam is produced from the fire tube boiler at 8 bar gauge. So, the pressure is given 8 bar gauge at which steam is produced, and it is the lab scale experimental setup, and the boiler is fire tube, steam produced is wet. So, in exam sometimes it may not be given that steam produced is wet. So, I am underlining this sentence, steam produced is wet. So, this is basically we have discussed in the context of fire tube boiler, because fire tube which indicates that flue gas is passing through the tube while water is taken through the cell, and steam is also produced. While steam is producing, you know, steam is getting produced, steam is in equilibrium with the water, and hence we are going to get wet steam, and the quality of steam is given 0.85. The water flow rate of 100 liters in 10 minutes controls the steam generation rate. So, that is the water flow rate through the boiler that is given. The boiler is diesel fired boiler. You know, if we try to recall, we have discussed many times that in boiler water is circulated, and upon receiving heat from external source it converted into steam. Now, when it receives water receives heat from external source, that source may be due to combustion of coal, or it may be due to the diesel fuel. So, basically fuel that is used for the combustion, it may be coal or it may be diesel like this. So, it is a diesel fired boiler. Reason is, you know, this is lab scale experimental setup. So, here it is very difficult to have coal combustion, and that is why it is diesel fired boiler. The specific gravity of the fuel is 0.89. During 12 minutes total 12 liters fuel are consumed. So, it is also given how much fuel is consumed in 12 minutes. The calorific value of the fuel is 44,265 kilojoule per kg. The feed water temperature is 30 degrees Celsius. It is very important because the inlet temperature of feed water is 30 degree. We need to calculate the boiler efficiency. So, let us quickly draw. So, this is the solution. We can start now. Solution. So, basically boiler, let us quickly write what is mass flow rate of steam. So, m dot s, that is steam generation rate, right. See, we have discussed again in one of the previous classes about the boiler efficiency. So, what is boiler efficiency? Because steam is produced at the cost of some input energy. So, when steam is getting produced, we are getting some enthalpy within the steam. So, what is the enthalpy that we are going to get, because it is given that feed water which is entering into the boiler is having temperature 30 degrees Celsius. So, there will be a change in enthalpy, and that change in enthalpy is obtained at the cost of the energy that we are supplying by burning diesel. So, from there we can calculate what would be the boiler efficiency that we have discussed. Now, steam generation rate, that is how much? It is given 100 liter, the water flow rate of 100 liters in 10 minutes control the steam generation rate. So, it should be 100 liter divided by 10 minute. So, 10 into 60 second. If we convert into kg per second, that is 100 into 10 power minus 3 into 10 cube. So, that would be kg divided by 600. So, this is coming as 0.166 kg per second, because we are familiar with the unit of mass flow rate kg per second, that is why I have converted the unit liter into kg. That is very intuitive. So, this is the steam generation rate, and also you can write the fuel consumption rate. Fuel consumption rate, it is given that total 12 liters fuel are consumed in 12 minutes and specific gravity is given. So, what would be consumption rate? 12 liter divided by 12 into 60 second. Now, if we convert into kg per second, then 12 into specific gravity is given 0.89 into 10 power minus 3 into 10 cube kg divided by 720. So, the unit should be kg per second, unit should be kg per second. So, this is kg per second and it is coming as 0.0148 kg per second. So, these two quantities we have calculated, because we have discussed that in a boiler there are two different streams. One is the stream of flue gas, other is the stream of water and steam. So, at least we could calculate the flow rate of steam and flow rate of fuel. So, knowing these two quantities, next we can proceed to calculate proceed with the calculation of the efficiency. By how? See, we also need to calculate, we also need to know the enthalpy of steam that is obtained at the outlet of the boiler, right. So, let us now move to calculate the enthalpy of steam that is being produced. So, pressure and enthalpy, pressure and enthalpy of steam that is being produced So, we have to calculate. By how we can calculate? Pressure of steam, it is given pressure of steam. So, I am writing Ps. What is that? It is already given that if we look at the first line of the problem statement, then it is written steam is produced from the fire tube boiler at 8 bar gauge. So, that is the pressure. So, this is equal to 8 bar gauge. Okay. So, that is I am writing I can I could have straightway written the final answer, but I am writing this is 8 bar plus 1 atmospheric pressure, right. So, that is 1 atmospheric pressure equal to 1.013 bar. So, this is basically 1.013 bar. So, total is coming 9.013 bar. So, this is the pressure, right. We have converted into bar. What about enthalpy? See, already it is mentioned that steam produced is wet. Even if it is not mentioned in the problem statement, since the boiler is fire tube, you should assume that you should consider that the steam which is produced is wet, because the produced steam will be in equilibrium with the water. So, now wet steam is wet, and quality equal to 0.85, that is given. So, quality is given 0.85, right. So, quality is given. Now, what we can do? We can calculate the enthalpy of that steam, wet steam, how much? So, Hs, that is the enthalpy of the wet steam at this pressure 9.013 bar, because this is the pressure at which steam will be available in the boiler. So, that is Hf at 9 bar. I am only taking 9, you can take 9.013 bar, because we will be taking we shall be taking properties from the steam table. So, it is better to take 9 bar plus x Hfg, this is also at 9 bar. So, you should not be confused, because ideally we are supposed to take 9.013 bar, but if it is the case, then we need to go for again linear interpolation from the by taking data from steam table, but we can we can also consider 9 bar. It will not be giving gross mistake. So, what we can do, if we take the data, this is 742.56 kilojoule per kg, 0.85 into 2030.5 kilojoule per kg. So, that is kilojoule per kg, and final answer is coming 2468.48 kilojoule per kg. So, this is the unit, right. Let me tell you once again, Hf, that is enthalpy of saturated liquid, that we will be getting from that pressure 9 bar, 9.013 bar from steam table, and that is enthalpy of mixture at that condition, and we also know x, that is given 0.85. So, only thing we are ideally this should be 9.013 bar. In that case, what we need to take? We need to go for linear interpolation. Instead, I have taken 9 bar, because the grossly it will not give that much erroneous result, and we are calculating H, that is enthalpy of steam that is produced in the boiler. Now, what would be enthalpy? So, let me write the efficiency of the boiler. So, boiler efficiency eta boiler equal to mass flow rate of steam into change in enthalpy Hs minus H liquid, that is feed water, divided by m dot fuel into calorific value of the fuel. So, this is calorific value of fuel. So, this is enthalpy of feed water. Right? How can we calculate enthalpy of feed water? Because if we go to the problem statement, it is given feed water temperature is 30 degree Celsius temperature. So, HFW, again if we try to recall the ideal or actual Rankine cycle, liquid which is pumped to the boiler is the saturated liquid, right, and then it is pumped to another pressure, that is the pressure of the boiler, right. So, now H feed water that is nothing is mentioned about the pump work, right, and if we consider the pump work is also not very, because in this case we really do not know what is the pump work. We also do not know because feed water temperature is given 30 degree Celsius temperature, that is at the inlet to the boiler. So, we shall consider that HFW, that is HF at 30 degree Celsius, right, and we can calculate it from stream table, and that is 125.74 kilojoule per kg, right. Had it been the temperature of feed water when it is entering into the pump, then this enthalpy plus the pump work would have been the enthalpy of feed water at the inlet to the boiler, but no information is given about the pump work. So, we are straightway considering that this is the feed water enthalpy at the inlet to the boiler. So, now we have calculated everything, otherwise calorific value of fuel is given, we can directly plug in the value of all these quantities. So, this is 0.166 into 2468.48 minus 125.74 divided by 0.0148 into calorific value of fuel is given 44,265. If we calculate it, we are going to get efficiency equal to 0.5936. So, that is 59.36%, right. So, this is the efficiency of the boiler. So, try to understand efficiency of the boiler is not even more than 60% from this particular example, and the data that we have taken to calculate the efficiency are obtained from lab scale experiment, and we can see the efficiency is close to 60%. Now, you may argue with me, because if we would have considered 9.013 bar, also if we consider the pump work which is added to the feed water before it enters into the boiler, considering all those aspects, even efficiencies either it will be less than this or it will go little higher than this, that we need to consider. Now, question is, why, even if we consider the efficiency is roughly 60%, then why 40% not available. So, this is very important. So, why this remaining 40% is not available? Question is, why remaining almost equal to 14% efficiency is not obtainable. So, this is question. So, this is the question. There are several factors for which we are not going to get this 40% of efficiency. What are those? Number 1, that is the heat loss through the flue gas. Heat loss through flue gas. So, that means if we try to recall the schematic of the fire tube or water tube boiler, we can see that the combustion chamber flue gas is produced, that flue gas is directed towards the top of the boiler, while it is passing through the water tube or it is passing through the fire tube, eventually it is going out from the boiler and going to the surroundings. And we have seen that significant amount of enthalpy, significant amount of energy will be lost if we do not take several attempts like economizer to heat up the temperature, to increase the temperature of the feed water or to heat up the feed water. So, we have discussed all those aspects. Even then we can see that significant amount of energy should is going to be discharged from the boiler without doing certain without doing the conversion. So, this is one thing. number 2 may be incomplete combustion. And unburnt fuel loss by the flue gas. And number 3 is heat loss from the boiler by conduction convection, by conduction, convection, leakage and radiation. So, these issues are there. So, incomplete combustion may be the fuel that is used, if we go to the mathematical formula of the efficiency, we can see that we are multiplying mass flow rate of fuel into calorific value of fuel. So, if certain amount of fuel is not taking part the combustion, then perhaps that would be loss. So, a loss of energy. So, that part is not going to be utilized. So, the incomplete combustion and unburned fuel loss by the flue gas. So, the fuel which is not utilized will be taken by the flue gas, and so that is again a loss. And heat loss from the boiler, because that boiler, when the combustion is taking place inside the boiler, some amount of energy will be lost through several modes of heat transfer, that is conduction through the wall, convection also by flue gas is going out. Also that conduction through the boiler wall and surroundings there is air flow. So, that flow will again try to enhance the heat transfer. So, that is convection, and finally, temperature is very high, then radiation effect cannot be trivially ignored, and there must be certain amount of heat leakage from the boiler. Accounting for all these aspects, efficiency is not achievable more than 60% that we have solved, that we have seen through the numerical problems which we have solved in today's class. So, that we have discussed, that is to summarize today's class, we have discussed about the classification of boiler, then we have seen the different flow cycles inside the boiler, then boiler attachments, necessary components, rather mandatory components, those are necessary without which boiler cannot be certified, but those components are not directly affecting the boiler performance. We have also discussed about the accessories which are not mandatory component, but these components directly affect the boiler performance. Then we have discussed about the characteristics of superheaters, and finally, we have discussed about one important issue, that the sole objective of placing superheaters in the boiler is to get superheated steam, to increase the steam temperature before it enters into the turbine. We have seen in practical scenarios, sometimes the temperature at the exit of the boiler is so high, at the exit of the superheater to be precise is so high, that we need to have temperature control. We have also discussed that part, and finally, today we have discussed, we have solved one numerical problem. By solving this problem, we have understood that efficiency of the boiler cannot be more than 60% at least from the data that we have taken for today's for the example that we have solved in today's class. And we have also discussed about the loss of, there are several issues because of which the efficiency cannot be achievable beyond 60%. So, with this I stop here today, and I also would like to complete this particular module of this class. From next class onward, we shall discuss the next module of this particular course.